Hello class, you're welcome back to this section. In this video, we are going to look at differentiation of trigonometry ratios. So that's what we're going to look out for in this video. So if you are new on this channel, kindly make sure to subscribe, like and share. Please make sure to like this video, okay? Like this video, give us a like. That's what we need from this video so we can get more engagement on this video. So without wasting my time, let's zoom straight away to our topic for today: differentiation of trigonometry ratios. Now, the concept about trigonometry ratios came into being where mathematicians wanted to find out how to measure angles when two or more lines meet and how to find the distance that exists between 2 points. So let's see. Basically, with our trigonometry ratios, it derives from a Greek word. It has two parts. We have the first part is what? We have what we call the trigon. The trigon is a Greek word, means what? Triangle. Triangle. And then metric. These are the two parts of trigonometry. And the metric means what? Measurement. Measurement. So actually, trigonometry ratios, we are talking about a special concept that help us to find angles within the triangle and also to locate what the distance that is between the vertices of the triangle, or basically the distance that is between 2 points on the triangle. I hope that is clear. So that is a concept about trigonometry. So and a trigonometry ratio, we have 3, but then before we move on to the trig ratio, actually let me do some illustrations here. This is a triangle I'm talking about here. So most of the times in special cases you see triangle that we apply the application of trigonometry. We apply the concept of trigonometry ratio in triangles. So actually that's what you're talking about. The trigon means a triangle and then the matrix of measurement. So let's say we have here to be A, here to be B, and here to be C. So for me to find the distance from A to B, actually it is based on this concept I can find a distance. Likewise, let's say A to C or B to C. Then also to locate the angles, here is 90. To locate the angles that exist between the triangle two, it is based on this concept that we're able to find the angle. So actually that is the concept about trigonometry ratio. We are talking about triangle and measurement. So how to measure triangles with respect to the distance and with respect to angles. But that's not what we are going to look out for. We are going to look at how we differentiate trigonometry ratios, how angles and measurement changes when we find a change between these quantities that we want to illustrate in this case. So that is the whole idea we try to build across in this video. So let's move straight away to talk about the trig ratios that we have. Basically, we have 3 mother trig ratios. We have 3 mother trig ratios. So let's see the 3 mother trig ratios I'm talking about here. So basically we have 3. We have first one, which is the sine. Second one, we have cosine. And third, we have tangent. This is the 3 mother ratio that we have in trigonometry, and it has given birth to other ratios. It has given birth to others. So in other books you see, it will say that we have basically 6 trigonometry ratios. Other will say that you have 3 trigonometry ratios, but then all are jet towards the same concept based on the perspective they are arriving at. So actually we have 3 mother trig ratios. We have sine, cosine, and then tangent. And this mother ratio has given birth to other 3 ratios to help us also to find the angles and distance that is between triangles within and then the outside the triangle. I hope that is clear. So when it comes to sine, sine, by convention you can write this as sine. Yes, S-I-N, sin. Or let's say sin, sorry, sin. Can write in this way. Then cosine. Can also write cosine as cos, C-O-X. cox, sorry. And then tangent 2, by convention, you can also write that one as what? Tan, as tan. I hope that is clear. And these ratios that we are talking about, as I'm saying, it has given birth to other ratios. And these ratios that we're going to talk about are basically the inverses of these three basic ratios that we are talking about, or mother ratios we are talking about. They are basically their inverses that we're going to discuss. So to find the inverse of sine, you say the inverse of sine is what? 1 over what? Sine. I hope that's clear. So the inverse of this sine is 1 of the ratio that sine have what? Let's say, let's use for the purpose of explanation, give birth to, and we call it what? Cosecant. We call it cosecant. So in other words, you might see CSC, or you might see cosec. This is what they will write, CXC or cosec. So whether it's CSC or cosec. So that is one ratio. We have cosecant. So once you hear of cosecant or cosec or CXC, we mean what? The inverse of what? Sine. And then when it comes to cosine 2, we also have to find the inverse of cosine, also what? 1 out of what? Cos. And then the real name for inverse of cosine, we call it what? Secant. So in other words, you might see, or in other words, you might see sec as xce as sec. I hope that is clear. And when it comes to the tangent 2, the inverse of tangent is what? 1 over what? Tan. So by convention, you can write as what? Tn. And the real name for the inverse of tan, we call it cotangent. Cotangent. So you see the sine is what? Cosecant. The cosine is what? Secant, as sec. And then the tangent is what? Cotangent. So that one too, by convention, you can write as what? COT in short. That's cot. So these are the inverses as I was talking about. So these are the mother ratios that we have, and they has give birth to, and their inverses has actually give birth to another ratios. That's the inverse of sine, which is what? Cosecant. The inverse of cos, which is what? Secant. And the inverse of tangent, which is what? Cotangent. And by the convention is that we write them in short form as cot, sec, and one CXC or cosec. So that is what we also need to know, so that once you start the real differentiation, you're able to understand where we are moving to. Okay, so in dealing with that, in dealing with these ratios, let me have the triangle down here again. Triangle here. I'm going to use a triangle to illustrate something here. So just stay carefully here. Come in. So let's say I have A, I have here to be B, I have here to be C. There is a right angle triangle. I hope that is clear, right? So now let's say I have an angle here. Let's say angle X. Now, to help us to measure the ratios, or to use these ratios to measure the distance and even the angles within the triangle, which is the trigon, as for the Greek word, right? We use trig ratios to do that. Now, we started with sine, right? Sine, to find the formula for finding sine in measure of what? Trig ratios. This is what we're going to do. First, here the concept that we are trying to build up here, we are starting from somewhere, so that when you get to the main real differentiation, you know the basis and how to go by. That's why I'm taking my time to go through this. So if you are still watching, thanks for watching. Make sure to like this video, okay? Give us a like so we can get more engagement on this video. All right, so now let's begin with the sine. The sine is saying that for me to find, let's say, the angle for X, this is what the concept of sine is saying. It says first, all that you need to do is to locate where the angle, this angle X, is which side of the triangle is it facing. and then that becomes what the opposite in that case. And then its other ratio they're going to measure is going to use what we call the hypotenuse. So the longest side of a right angle triangle is hypotenuse, and then the other side is going to be based on where the angle that we are into consideration is going to be. So if we are consider angle X at the down here, then it's going to, the opposite is going to be this side. But then if let's say the angle was here as Y, and we are considering where to be opposite, where the Y is facing, at the side of what BC, that's going to be what the opposite. So for length AB and BC, changes with respect to the angle that we are taking into consideration. I hope that is clear. So since we are considering just angle X, AB, length AB becomes opposite, and then BC becomes what? Adjacent. Adjacent. Let's take note of that. Write it all. Oh, sorry. Adjacent. And here becomes what? Opposite. Opposite in that case. So sine is saying that for me to measure angle X from this triangle is going to be opposite, which is what? Length AB over length what? AC. So that's the concept of our sine. So it is what? Opposite over hypotenuse. So most of the time in some books you see as what? To help you to remember the formula, you see as what? SOH. As what? So that's opposite over what? Hypotenuse. That's sine. And then when it comes to cos, that's the cosine to also the angle that we are taking into consideration are going to determine the formula. And they are always their denominator is always what? Hypotenuse. For sine and cos, their denominator is always what? The hypotenuse. Is that okay? But then their numerator changes with respect to the angle that we are taking into consideration. So they aren't the same. And cos is also saying that where I'm facing, where the angle that we are taking consideration, where the angle is facing, that's how it becomes what? The opposite. But that's not what the cos approach is looking out for. It's looking out for what? The other side. So where I'm able to locate my opposite, the other side becomes what? The adjacent. And that's what the concept about what cos is saying, that this is what I need to work with. So with cos, let's say cos X is going to be your adjacent. So here the adjacent is going to be what? Length what? BC over length what? AC. So that's the concept about cos. And then tangent is also another special case. For tangent, it just deal with the opposite and then the adjacent, and always the emphasis is based on the angle under consideration. I hope that is clear. Always the emphasis is based on under the angles that we are taking into what consideration. I mean the angle that we are taking into consideration. That is what the concept about tangent is also going to build on. So let's see. So with the tangent 2, by comparison, we can write as this tan x is going to be, so here, which side is angle x facing? Is facing or length what? AB. So that length AB becomes what? The opposite, which is what? AB. And then the other side becomes what? Adjacent, which is length BC. So always to tangents also have what? A formula called opposite over what? Adjacent. I hope that is clear. Cos 2, its formula, its base formula is what? Adjacent over what? Hypotenuse. Hypotenuse. So that is the concept about what. So for you to help you to remember these formulas, we have certain let's say mnemonics, or for you to help you to remember, we call it so and ka toi. So means sine, opposite over hypotenuse, ka, adjacent over hypotenuse, and toi, opposite over adjacent. That tangent. So that's the concept that always helps students to remember this concept very well. I hope that is clear. Right. So that's something we need to know when it comes to this. So the inverses of this. So let's say sine. We say sine is what? Opposite over hypotenuse. So for me to find the inverse, which is what? Secant, is going to be what? Hypotenuse over what? Opposite. And that's going to be the formula for what? Cosecant, CSC cosecant. And then cos 2, we said is what? Adjacent over what? Hypotenuse. And to find the inverse of what? Cos, we said the inverse of cos is called what? Secant. So here is going to be hypotenuse over what? Adjacent. So that's going to be your secant. And then when it comes to tangent, that's tan. Let's say tan x, sine x, cos x, and let's say tan x is going to be opposite over your adjacent, and that the inverse of tangent is what? Cotangent, and that one is going to be what? Adjacent over what? Opposite, right? So that is only going to be cot in that case. But then at times we always want to make some comparison when it comes to these trig ratios. We always want to make comparison when it comes to these trig ratios. So let's say I want to compare sine and then cos. So let's see something here. If I'm comparing sine and cos based on what I was having here, realize that sine was what? A over AB over. So let me limit so that you become okay. So let me have it here. I think that's going to be so. Let's say let me have the triangle here once again. Here is A, here is B, here is C, here is 90, here is what? X, angle X. Let's say here is P, Q, and R. How that's clear? So here we say sine is going to, if I'm considering X, then going to what? P over R. Let's say equation 1. Cos X, cos X is going to be Q over what? R, and then tan X also going to be P over what? Q. So now I want to compare sine and then cos. So in comparison, I can say that sine x is to what? Cos x. Let's see how the comparison is going to be. I know sine x is what? P over R, right? Compare with, I know cos was what? Cos x is what? Q over R. Remember, these ratios can also be expressed in a division form. Is that okay? So I can say that my P over R, right, in this way, my P over R divided by my Q over R going to be, so here becomes what? PR, the reciprocal form, multiplied by R what? Q. So it's going to what? R cancel, I'm going to get P over what? Q. I believe that is clear. So with this P over Q here, which of the ratios is similar to? You can see that it's similar to a tangent. So at any pace, we can conclude that tan x is equal to what? Sine x over what? Cos x, as is here. This one is the same thing as sine x over what? Cos x. I mean this one is the same thing as this. What we have here, which is what? P over Q, and then tan x is also P over what? Q. So for you to find tan x is also equal to what? Sine x over what? Cos x. So that's what I'm trying to put across here. So let's take note of that. Alright, so now let's move on and talk about the actual differentiation based on the background information that we have derived from the concept of trigonometry ratios and in relation to differentiation or changes that exist between these quantities. So let's see how we find the derivatives of these functions. So if you are still watching this video, thank you very much for still watching. Please make sure to like this video and subscribe so that we can get more engagement and then to help assist you to pass any examination and mathematics exams you may engage on. So let's continue to talk about the derivatives or the differentiation of these trig ratios that we are talking about. So now let's begin with sine. Let's say sine x. All right, so for me to find the derivative of sine x, I will say that differentiate sine x with respect to what? X always when you are to differentiate sine x, it results in what we call cos x. Please take note. At any time you differentiate sine, it's going to result in what? Cos x. So it's going to result in cos x. When you differentiate cos, so the differential of cos x is also going to result in negative sine x. So take note, it's very simple. When it comes to differential of what? Sine x, it results in what? Cos x, which is positive, right? When it comes to differential of cos x, it results in what? Negative sine x. So all that you need to know here is that here the differential of cos will result in negative sine, but the differential of sine is what? Cos x. Is that okay? So let's keep this right away. Now, when it comes to the differential of tangent tan x, so differential of tan x is also result to what we call secant, as a squared what? X. So that is the base rule. Once we get these rules down, we have cos x, sin x, negative sin x, and sec square x. It is enough. We can do everything based on the inverse formulas for these approaches. Once we get all these and up to this stage, then you are good to go. Any question on trigonometry with respect to their derivative, you should be able to deal with them and deal with it very clearly. I hope that is clear. So that is what we want to know. Is that okay? So for now, the differential of sine x is what? Cos x. The differential of cos x is what? Negative sine x. Then the differential of tan x is what? Sec squared, that's secant x, right? But then let's see how we derive, especially tan x, how we arrive at sec square what? X. So let's see. Let's prove that one. But for the rest, it's simple, so you can take on. So we are saying that tan x, the differential of tan x is going to result in sec squared x. How do we engage in that? Let's see. So with this approach, the whole idea we're trying to build upon here is that we said tan x can also be the same thing as what? Sine x over what? Cos x. Cos x. That's what we said. If you remember from the comparison that we made with respect to sine and cos. Hope that is clear, right? So now for me to differentiate sine, I can store. I'm going to use tangent at tan x, so it's the same as sine x over cos x. This is what I will do. I'm going to use what we call the quotient rule. If you remember the quotient rule, in the part 2 of this video, we discussed intensely about quotient rule. Kindly make sure to, after this, kindly visit that link. They are on the description section of this video to watch so that I can get the understanding clearer. If you are still new here on this channel, thank you for watching. Kindly make sure to like and share. And if you are getting some value out of it, comment below so I can see that you are getting the value out of this presentation. So let's continue. So in this case here, this is what we are saying is going to be, so the difference I'm going to use the quotient rule. The quotient rule is saying that if I have, let's say, dy over the is going to be, we make reference to two functions or two variables, which is what? V du dx, v du dx, du dx minus u dv dx all over what? V square. I hope that's clear, right? So in this case, all I will do here is that now we know tan x is equal to what? It's equal to sine x over cos. I can say that the differential of sine x over cos x is going to be, so let's say here, let's make a representation, right? Even before we start with the differential, let me make some representation so I get it clearer. So I can say that let tan x will be equal to u over what? V. Meaning that in this case, sine x is going to be u and v is going to be what? Cos x. I hope that is clear. Cos x. So in this case, I can say that u is equal to what? Sine x, and v is equal to what? Cos x, right? So here I'm differentiating u with respect to what? X. So here I'll differentiate individually. We said the differential of sine x results in what? Cos x, right? And we said the differential of cos x results in negative sine x. So once we get this one down, then we can quote our formula once again, that therefore the differential of tangent, which is the same thing as tan x, which is the same thing as sine x over cos x, is going to be, so I know my v as what? Cos x. So I have my dot here, and I know v will move what with the u, so 2v don't move together. Okay, so v will move what to the differential of u, so it's going to be cos x minus, I know my u is what? Sine x, so sine x, and I know the v over dx for is going to be also going to what? Negative sine, so it was negative sine x. So let's take note. So here, all divided by, I know v is what? Cos x squared. So cos x, sorry, so I'll square it based on the formula. So as we are having it here, we have cos x squared plus sine x squared all over cos x squared. So here is going to be, I know, so one thing also about trigonometry here is that if I have cos x squared plus sine x squared, going to result in what? 1. Going to be equal to 1. So if like, I can use calculator, send the calculator, and then key these functions on the calculator, the addition is going to result to what? 1. So let's take note of that. Going to result to 1. So therefore I can say that cos x squared plus sine x squared is going to be 1. So it's going to be 1 over cos x or what? Squared. Oh, that is clear. So here in this case, I can say that here is going to be, if you could remember, we said when we were discussing the concept about the inverses of the mother ratios, we said the inverse of what? Cos is what? Secant, right? So therefore I can say that 1 over cos x is going to be what? Sec x as secant x or what? Squared. So that is the differential of tan x. Differential of tan x is going to result in, so in other words, you might see this sec squared what? X. It's the same thing as what I've written here. They are the same. Okay, or you might see it as, let's say, sec, let's say x all squared in this one. So they are all the same. So let's take note. So then that's how we prove for the concepts or the differential of what? Tan x. So let's take note of that. It says square what? X. It says square, that's secant square what? X. So that is how we read it in that case. So let's take note of that. I hope that is clear. So let's take some examples based on the idea we have built right from the first stage up to now. So let's take some examples and let's see how we go. So this is an example 1 under differentiation of a trigonometry ratios. So now we are asked to find the dy over dx of the following function. So first I'll start here. We said the differential of sine x is going to result in what? So can say my dy over dx is going to be what? Cos x. That's what we said, right? So here too, the differential of cos x is going to be, so dy over dx is going to be negative what? Sine x. I hope this one, they are simple, you can go. And the differential of tan x is going to result in what? Sec square x. So let me bring this one before. So I can say that my dy over dx is going to be c squared of x. I hope that is clear, right? So let's look at